Hello friends, welcome back to the bench. Thank you very much for joining me. Our patient is the board from yesterday for the socket replacement. The socket is, what was it, 1366? It's in the comment of my previous video. Someone told me what this socket is. Not to worry, because the customer sent us a socket for replacement, so we don't have to worry about that. Actually, we need to check if it's if it hasn't been damaged during shipping, because sometimes they do. Typically, the first step I do is to clean the board very well, because then I have to stick the thermocouple somewhere close here and put a whole bunch of Captain tape around it to hold it, which gives very nice results. However, from time to time, it will detach from the board and give you a little crappy results, or a little lower, poorer results. And what I noticed is that if your contact with the surface, the contact of the thermocouple with the surface is not, say, perfect, meaning it doesn't show you 140 degrees at least when you heat up to 220 to 200 at the bottom, that means you have to adjust your profile. And that is one of the issues we're having right now, because tons of you guys are requesting profiles for different devices. And of course, I have some profiles that I can give you, but it's never going to be a plug and play kind of thing. You know, it's not like you can take my profile and reproduce it and have the exact same results on your machine. First, the machine is going to be slightly different. Second, the thermocouple, your environment is going to be different. Obviously, the board, well, if it's a profile for, say, PlayStation 3 particular chip, then, you know, the boards are technically the same, so no issues there. But the environment, the bottom heater, all of these things are slightly different, and the most important part is the attachment of the thermocouple. So depending on how you attach your thermocouple, you may need to adjust the profile, meaning reduce the temperature. And the only way you're going to find that out is by performing that a few times and just starting from the lowest temperatures you can, and then bring them up. If they don't work, then start bringing them up, and that way you'll find the lowest temperature that actually works. And, you know, in my case, it's typically 230, 235. In your case, it might be 215, 210, right? It all depends on how the feedback is taken into account by the machine. Now, today we're going to use version 1.1, early version. It is still in the works, so it's not going to be released for a while, but this version allows you to actually adjust the PID values of the controller and see them as well. So in some cases, you will have to adjust the PID controller for whatever work you're doing. There's going to be some instructional material that I will deliver with the software to kind of help guide you through that process. But it is a little intricate. It's not as simple, but the easiest or the most effective way of adjusting PID controller is by trial and error. No matter what kind of math you use to kind of catch this region where it should be, to actually find the sweet spot, you need to use trial and error. I'm not aware of any better method than that. I'm working on the calibration software that will allow you to just run the profile, the pre-programmed profile that will measure how your or detect how your machine is behaving, and based on that adjust the PID values. But that's long in the works, and it's not going to be released for quite a while. Now, from you guys, someone recommended this to me on Discord, and so even sent me the link. As soon as I saw it, I purchased it because it looks awesome. So this is gooseneck, right? like for the lamps and stuff, LEDs. Typically you get LEDs on these. And I was actually looking for one of these in my local stores around, but I couldn't find any. Then we have two neodymium magnets over here in aluminum cover. And this sticks to metal. Well, looks like this is aluminum. Okay, so it's not gonna stick to that, but it'll stick to this. But it's very weak. It's so weak that it doesn't support its mass. It's too heavy for those two tiny neodymium magnets. So I'm gonna try to attach it with some zip ties to make it stable, and we're gonna test it. Obviously, this is not the first test I'm running on this. I did pretty extensive testing, a few hours of all kinds of typical work, heating up, preheating, replacement, removal of whatever. I removed one of the RAM sockets, RAM slots, DDR4, because someone wanted the numbers, and that's 220 at the bottom and 320 on the hot air to remove it. It melts slightly, but there's no smoke or no damage to the board, so it works well, at least on my board. But this is somewhere the region of the temperatures you need to use. Obviously we can use the top heater of the IR6500 station because it's not big enough. It would just melt, or it would just melt solder under half of the RAM stick, and you still need to use the hot air. And then it's in your way, the heater is in your way, plus hot air. Nah, not worth it. There's just, as long as you have good bottom heating, you can use hot air, and it's a lot easier. Obviously it takes a while, because hot air takes a lot longer to heat to the target temperature, and it cools a lot quicker. So it's different than using IR. IR is a lot faster and a lot stronger. Okay, to use this on IR6500 stock version, you need to open the bottom plate and rewire the thermocouple the other direction because it's wired wrong. I have a video on that somewhere in my library. So once you rewired it, what I do, I just left a little piece outside, right? When it comes in the mail to you, the wire is going to be sticking like this much, and it's very flimsy. And what we want is a good contact with the surface. So this makes it a lot more springy. But the contact, I'm not happy with the contact. It's better. I get better results when I actually put the Kapton tape and stick it on with a Kapton tape. But that is when the Kapton tape really sticks to the board. Some boards, and this is one of those boards, the surface over here is not ground, the top layer. We see the traces going to the memory, which means it's a very wavy surface. So the Kapton tape is not going to stick very well to that. On the boards where the top layer is the ground plane, it sticks very well, but not on these. So in this case, I wouldn't even use the Kapton tape. So it's since you're going to have few thermocouples, right? You should. Just depending on the job, pick one that works. So in this case, I have to use this one because I know the Kapton tape is not going to stick. Okay, we need to clean this side, but other than that, it looks good. The socket is good. So this is going to be my first attempt of doing the 1366, was it, or 1633? I don't know. But first time doing this socket, so let's see how it's going to go.
I live inside my own world of make-believe. Kids screaming in the cradles, profanities. I see the world through ice covered in ink and bleach. Cross about the ones who heard my cries and watched me weep. I love everything. Fire spreading all around my room. My world's so bright, it's hard to breathe, but that's alright. Hush. Take my eyes open to force reality. Why can't you just let me eat my weight in glee? I live inside my own world of make-believe. Kids screaming in their cradles, profanities. Some days I feel skinnier than all the other days. Sometimes I can't tell if my body belongs to me. I love everything. Fire spreading all around my room. My world's so bright, it's hard to breathe, but that's alright. Hush. Content, hold your breath and feel the tension. Devils hide behind redemption. Honesty is a one-way gate to hell. I wanna taste consumption. Breathe faster to waste oxygen. Hear the children sing aloud. It's music till the wick burns out. Be carefree lately, yeah. Just kicking up daisies. Got one too many quarters in my pockets. Counting like the four-leaf clovers in my locket. Untied laces, yeah. Just tripping on daydreams. Got dirty little lullabies playing on repeat. Might as well just ride around the nursery and count sheep.
Alrighty, now a postmortem. What happened? So I was considering stopping the process because the difference between this thermocouple and my reference thermocouple was over 80 degrees. I'll review the footage in a minute, but I didn't because I did want to see what's gonna happen, right? Unfortunately, it's a customer board, so I broke customer's board. Sorry about that. I mean, there is always a risk that it's not going to work, but typically something like this doesn't happen. That's the first time. But it exactly what we expect to happen when the thermal feedback is faulty. So board obviously is overheated. We don't need to even describe that. We have pulled pins, the data pins probably, because these fly off very easily. And here, obviously the socket melted. Cleaning this is possible. Ultrasonic cleaner is not going to clean this, but it's possible to clean it. I cleaned it on a few boards, but once the socket melted, then the board is damaged as well. But as you can see, yeah, you can clean it, right? A little brushing and stuff. So, you know, if it wasn't for pulled pads, I would clean it and I would resolder the socket. But in this case, it's not worth it because we don't know what those pins are, but we can check. But the probability that all of these pins are redundant and they're not going to impact performance is none. Is absolutely none. But in addition, the board, as you can see, bubbled, right? So this is now unreliable board. We don't know if the vias are not detached. Most likely some of them are. So the board is dead. But what happened, or why does that happen? See, in this process, it's not about the top temperature. It's not about the highest temperature you achieve. It is about a profile. So take a look what happens, because I started pulling, because I knew that the actual temperature was much higher than the thermocouple showed. So I started pulling the socket, and it was already lifting in some places. But the heater was staying on 100 degrees, and actually let's review that. So we started normally, and preheating to 200 at the bottom gave us below 100 degrees at the top. So this was 10 minutes here preheating. So that already tells us that the thermocouple is not reading the temperature correctly. It should be closer to 130, 140. And the second thermocouple did show us that. So we know that temperature was reached, but this one was not reading it. So it was roughly of 30, 40, 45 degrees behind, right? 45 degrees behind is not horrible yet, because, well, it's not horrible yet, but it is definitely concerning. Then we started ramping, right? But note that our power goes up over here and it stays at 100%. That should never happen. That should never be the case. The power line should always be choppy, like this. In every procedure of mine that you can see, my previous procedures, this line, the green line, never settles. It always fluctuates. And that is the secret to actually performing this repair. The temperature must grow at steady rate to a certain point, but never with 100% on the heater, because if we have 100% on the heater, and look how slowly the temperature rose up to this point, and then I moved the thermocouple because I pushed it inside the socket, right? So then I moved it outside, because that's how normally I do it with the previous thermocouple, and look at this huge drop, right? Obviously there wasn't a drop like that, but the heater started compensating again. So we kept 100% over here, and that's where the damage happened, in this region. That was already a damage, and technically the machine thought we were at like 140, 150, 160 degrees, but we were actually closer to 200, maybe 20, 230. Then it stabilized for a little bit. We can see that the power was fluctuating here. So the adjustment of the thermocouple did improve a little bit, but again, it went to 100% over here. This is where the socket started melting. The actual temperature, you see 180 over here, but the actual temperature was probably around 250, maybe even higher. And yeah, and the rest you've seen. This is where I stopped the process, and well, actually, this is where I pulled the socket, right? But you've seen how that socket looked. Well, actually, we can see it here right now. It completely melted, but it still, see, it pulled some pins, it pulled some pads. So the socket was melting already, but the board wasn't hot enough. That's the whole trick of this procedure. The temperature needs to grow slowly. If you throw 100% on the heater and just wait for it to detach, then the top of the socket is going to be melty, as you can see, completely melted, and the bottom is still not going to be melted. The solder is not going to be melted. Now, what do I expect happened? Because as I said, I was doing some testing with it, and I didn't have such horrible results as I did now. But I think that this is what happened. Yeah, like this. The thermocouple was touching the metal over here, and that could have interfered with the measurements, or the metal over here was just acting like a heatsink, right? Maybe this would be better if we used it like this. Maybe. And that's what I think happened, but I'm gonna have to perform few other procedures to actually pinpoint it. But I need to find more, which is weird because yesterday I did a lot of testing and I didn't have bad results like this. And it's really too bad that it happened on the customer device. But as I said, there's always a risk of this not working, but never to the extent of melting the socket this bad. That has never happened. I mean, it happened when I first started doing that, but even when I first started doing this, I did not have results like this. This is the absolute worst. It was to be expected when you start using new, especially something so crucial as the thermal feedback. If you're changing anything in it, then you definitely have to be aware that something might go wrong, right? And this went wrong the worst way it could possibly have, destroying the board. Because if it just melted the socket, that's fine. I've done that before, but not to this extent for the board to actually deform. And that brings me to the moral of this story. The profiles are only worth as much as your thermal feedback. If there's any problems with the thermal feedback, none of those profiles will work. So again, if you want to copy the profile, use the profiles from Rework Pro, just one-to-one. Be aware that your machine might be different. I updated or upgraded my top heater from 400 to 450 degrees watts. Sorry. So that is the difference between the stock machine. Also, the stock machine has that red plate at the bottom, and there's a lot of different factors that can impact the results. But the most important is the feedback. And hopefully in the next video I'll have a perfect solution for this. But at the moment, I probably should have used the old method and just used the old thermocouple. Because I know I connected the other thermocouple to the controller, and yeah, it is 10 to 15 degrees off, but that was the case always. I don't know how to calibrate it. I need to look into that. But that 10-15 degrees of difference is not a huge deal. Yeah, the thermocouple shows you 15 degrees in the room. The room temperature is 15 degrees when it's actually 25. So it's always 10 degrees behind. But that 10 degrees is it's not the same throughout the whole spectrum. It tends to be a little higher at lower temperatures and a little lower at higher temperatures. Alrighty, so I hope you guys learned something from this failure. I sure did. It's kind of unfortunate because I didn't really learn anything new, but it's good to fail from time to time, to just kind of remind yourself that there's a lot of stuff that can go wrong with this. And one of the reasons I'm releasing this video is to show you that I'm not immune to awful jobs, right? Because you might get this impression, like on all my videos, the sockets go off very easily. The whole process works really well, and you just see this sped up footage by 15 times. with some nice music, and it takes 2 minutes, and the board and the socket is resoldered. There's a lot that goes into it, and a lot of things can go wrong. So if you're having these issues, especially initially when you're starting, that is to be expected, and don't get discouraged by those results, because you have to suffer at least 10 of these before you get the first successful repair, first successful replacement. So be patient and keep trying, and it will work. Alrighty, thank you fellas very much for watching. I do appreciate you, and I shall see you in the next one, and hopefully we won't break any more boards.